framework. Hot chocolate, red off well. Azure Cosmos Data. Entity framework, power tools. Technology suite.
Countdown commencing. T-2 minutes.
Jeremy Lickness.
Shay Rojansky.
Grace Lanson. Arthur Vickers.
.NET Data. T-1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Standup.
Hi, welcome to another .NET Data Community Standup, and as we should do more often, we have a community guest here. So, Victor, I should have asked how to pronounce your name beforehand, but here's Victor. He could tell us how to pronounce it, and he's going to be talking to us a bit later about window functions and EF Core and an extension that I believe his company makes, right, Victor?
That's correct.
Okay, awesome, good stuff. And then it's me and Shay as usual from the EF team. I'm going to very quickly show State of the Unicorn, but this is exactly the same as last week. So even though it says upcoming releases, it's not really upcoming. But the main thing is 8.02 is out, 25 bug fixes in there. Make sure you get it, try it out. Let us know if you run into issues really as soon as possible. Let us know if you run into issues because we hate to break things in a patch. But when there's 25 bugs, it does sometimes happen. And then, of course, there's EF Core 9 Preview 1 out. There's What's New out there. You can download that. You can run through all the examples. There's not a whole lot of features because we're kind of working on big architecture stuff. But go try it out. Might be just what you're waiting for. And even if you're not, try it out so that things like the query pipeline, we found out sooner rather than later that Shay broke it, basically. So that being said, enough of that. Let us now go over to Victor. Hey, Victor. So you want to introduce yourself and give us a little background on what you're going to talk about?
Hi, guys. So I'm Victor. I'm CEO at Zomp, or CTO, actually, CTO and founder. Small company based in downtown Toronto, Ontario, Canada. Basically, we take a bunch of client work, and one of the clients, the biggest client, there was a need to implement window functions for the project. So we started writing it by hand. Basically, what what ended up happening very soon was that the SQL became more complex and more complex and more complex. And then not only that the SQL became complex, we had to basically start breaking the SQL into different chunks because basically what we had a grid, and if a grid is sorted one way, we need to run the window function. If the grid is sorted another way, we don't need to run the window function. And basically, it was completely, it messed up our code really, really, really bad. And basically, we had a choice: either write an extension or continue producing crap code.
Right.
And
not much of a choice.
yeah, it wasn't much of a choice too. And then, we kind of like looked around. There was the issue, obviously, in the EF Core GitHub. And there was like no documentation like about how to write extension, except was one person, Pavel Ger from ThinkTexture, who basically he had like an extension that did two great things for us. I'm sure there were more, but one was subquery and another one was row number, right? But the row number was basically using, it didn't really implement its own SQL expression. It was using the existing SQL expression from EF Core.
Right. It's worth mentioning, so row number is an example of one of these window functions, and EF actually does generate row number with over internally, but it does it only for its own purposes, so to translate certain link constructs. So a user can't say, use this row number thing. It's rather a detail, an implementation detail of the EF query pipeline, but it does mean that at least the expressions are supported inside EF itself.
Yeah.
Yeah, and but basically we needed a lot more than that. But what we ended up doing, we took that that SQL expression and made our own expression called window function expression or something like this, which took the function name, expression parameters, orderings, partitions, and stuff like that, right? And then from that point, it was it wasn't too hard to like implement a bunch of functions. So yeah, maybe I can start showing.
Yeah, let me show your because you prepared some slides, which is like really professional for us here. So.
Yeah,
absolutely. And I know these slides also. So yeah, obviously we don't want to assume that everybody knows what window functions actually are in the audience. I know a lot of people don't have any clue of what a window function is. It's a feature of SQL. So yeah, I mean, I think we're going to learn about that together now, which is super cool.
Yeah, awesome.
Yeah, I asked my mom. She knows select and where, but she didn't know window functions. So
I don't think my mom would know it either. So your mom is in a good place.
Yeah. Okay. So all right. So yeah. So like right off the bat, I'll acknowledge the guys because like this is open source. We all copy from each other. We all depend on each other. So Pavel Ger, Irzak Ben-Gan, and the EF Core team, of course. That's without you guys, this wouldn't have been possible. We have like a small data set here, very, very simple data set. That's kind of like the data set we're going to work with. And then let's go into the first example. Basically, for every one of these rows, we want to generate another column that contains a count of everything that's in this like a count of every row, right? So it's going to be 9. There is a nested approach and there is a window function approach. Nested approach is basically you have like you're selecting, so this is your first select expression, second select expression, and then the third select expression is a complex expression where you basically you have another from clause, right? And you're basically selecting a count of everything and putting it into the third column.
Right. So this is not yet window functions. It's just a subscalar, a scalar subquery. Excuse me. So it's basically just a subquery approach to calculate, to add a column with the number of rows, and it's going to be the same for all the rows, right?
Yeah.
Exactly. So is this going to rerun the count every time for every row?
That's a good question. So let's actually check what it's
Yeah,
gonna
why
do.
don't we?
Very cool.
All right.
I hope I'm not derailing the conversation here with my limited
That's
SQL
what we
knowledge.
do here.
I know.
There's nothing more I love than being derailed, honestly. All right. So there we go. We have a. Remove this for now. All right. And let's run it. Okay, so we have, well, basically it's the same. Then what you want to do to see what kind of plan you have is you want to enable, by the way, is the font, I'll maybe increase it just a little bit.
Yeah, that's better. Thank you for doing that.
Okay, so you want to enable actual plan and then run it again. If you don't want to look at anything else, you want to look at this number here, the 65%, which is for the first, which is how long the first query took to run, and then this query, 34%, which is a lot more efficient, right? And then, do you guys know how to read this stuff?
I mean, I do to a certain extent. It's up to you if you wanna, dive into it all the way or not. I mean, we don't have to.
Yeah. Okay. Let's maybe another time, but like it's probably gonna take a while because like I also like know very little about it, but I guess is it right to say that these two numbers are what you're the most concerned about?
Yeah. So the window function one is clearly more efficient, right?
Yeah.
Right.
And there's a reason. It's a more. If we go back maybe to the slides and we see the two sequels right next to each other in the slides. So I mean, this was SQL Server, the plans and the cost and the cost calculation and so on. But I actually suspect you would see something similar in other databases. But I don't know. That's always a thing that needs to be checked for real rather than assumed. But I'm assuming that first of all, with SQL, one of the main things is that the second one, the window function approach, basically conveys more information to the database. The database can see through the query, like the meaning of what is actually being done, whereas the upper one is a subquery, which by definition already makes it a bit more difficult to analyze. It could, a smart database could like see through the subquery as well and make it just as efficient, but you always want to express things in a more, expressive and way, basically. I think what the window function one does.
Yeah.
But, sorry, I'm talking a lot. Maybe I'll hand it back.
No, I think Victor's fixing his audio, so that's good.
No, I'm fixing my monitor. Yeah.
Okay. So in the second case, instead of just saying, okay, because we need count as one of the columns, we're gonna calculate it every time through. We're using that over, and that's what makes it a window function. Is that right? And so over with just parentheses like that means over all of the rows in the that you're selecting.
Yep.
Okay.
I think Victor is maybe busy configuring, so I'm nodding my head and that's maybe not.
Are you with us, Victor?
Sorry. Yeah, I just. Anyways. Yeah, I'm back. All right, let's keep going. Just next example.
Right. So the new syntax here, the thing that Arthur was referring to, I'll just say is the thing that nobody knows if you've not encountered window functions before is this over clause. It's a new clause that follows a window function. And the window function here is actually, there's a big overlap with aggregate functions. So people who know group by already know aggregate functions like count. And the thing with so when you use count with group by, it works on the entire grouping, but group by actually collapses all the rows together to a single row. It reduces the rows, whereas window functions don't do that at all. So you see that every single row in the original table, the test rows table, is in the output. This is the difference with group by, right? Group by would not have this output at all. Instead, you would have some sort of maybe one row or whatever. But what window functions do allow you to do is access other rows in the table for each row that you're looking at. That's basically the definition, I think. Victor, correct me if you have a better way of thinking about this, or if what I'm saying is wrong in some way.
I think that's about right. All right. Sorry. I was just like setting up monitors. All right.
Okay, no problem.
I actually realized you need 3 monitors for this thing, not just 2. Because you've got the samples, you've got the screen share, and you've got the people. So
yeah, presenting is always a challenge. That's always.
Yeah. Sorry about that. Okay.
So we had a quick question here about whether count is expensive to run, and I think this is interesting because it's the point is not really whether or not count is expensive to run, but are you running it only when you need it? So in this case, effectively, and as Shay was saying, the database engine could optimize this, but effectively you're saying, even though count is going to be the same for every row here, we're telling the database we're going to count it for every row. Whereas here we're saying, actually, we don't want to count, we only want to do the count once. And so it's not really that count is expensive. And so, yeah, it might be that count is really cheap. And actually there's no practical difference, but to just understand the semantics of what you're telling the server, as Shay said, you're giving it more semantic information about what you actually want, so it's better able potentially to produce a better plan. And then, of course, as we go on to other examples, there are other advantages as well.
Okay. All right. So let's do the next one. So this example, it's a slightly more complex example, and it basically. So we want to find the minimum so far based on previous rows, right? So here it's 10, then it becomes -1, goes -1 until it hits the new minimum, which is -12, and then the last number is obviously greater than -12, so it's not going to be it's going to stay at S12. So the difference between this example and the previous example is that here the inner clause has it depends on the outer clause, right?
This is what we call a correlated subquery, right? Mm-hmm. The inner clause is referencing something from the outside, which means that it has to be recalculated for each and every row. The subquery again and again and again.
Yeah.
But that also makes it an interesting example compared to the previous one, because in the previous one, remember, the result of running the nested query was the same every time. Here, yes. It absolutely isn't. It's a different query every time because there's a different value of test row's ID coming out every time from the outer query. So here we're using window functions for something that's even, I think, more powerful than the previous example.
Absolutely.
Yeah. All right, and then if you basically, you guys.
So should we? Can you talk through, Victor, the query with the window function, like how we're managing to get it to only use the rows that we wanted in each case? Does that make sense?
Right. So so I guess the key thing here is this order by ID, right?
Right.
So I guess it's kind of like sorts it beforehand, and then as it builds this minimum so far, it goes like result by result, like row by row, after being ordered, and outputs the result. That's how I understand it.
Right. So I think the thing I remember when I first read about window functions, and one thing that's a bit confusing. So inside the over, we're saying that the window function works over the entire rows, but because they're ordered, implicitly that means that for each row, the row will see all the rows before it as with the ordering. That means that when we're looking at the fourth row as ordered by ID, then the minimum, the window function sees all first four rows, but it doesn't see the fifth row or the sixth row. That's implicit. That's the thing that I remember. I couldn't understand why this works.
Yeah.
And I think this is also where, by the way, performance comes in as well, right? Once again, you're expressing in a very, very clear way what you want, and there's some semantics here. And the database engine, when it does this, imagine how it actually does this. It really does row by row. And because the window function is defined as such, it's not an opaque subquery, correlated subquery or whatever. It can actually, maintain state from each row. And remember, up to now, the minimum that I've seen was -1. Is the next row going to be less or so? It doesn't have to actually recalculate the minimum for every row, which is what the nested approach does. Instead, it just does one pass and it maintains state. Basically, the window function has state from the previous row. This is actually the amazing thing. The query is not only much easier to understand once you understand window functions. That's not a given, but it really expresses things to the database in a way that allows for very powerful optimizations. Really, really powerful. Does that make sense, more or less?
Yes, definitely, yes.
Yeah.
Hey.
Right.
Yeah.
Next example?
Well, now, basically that's what we kind of like talked about, like why even build this library, right? So we kind of do this one. So let's keep going. And then basically this is a script. I personally like to start, like I have all these scripts stored away for like whenever I need to start a project, and I don't need to like open the IDE and think about how to spin stuff up. So this script here is I'm just going to paste it into a PowerShell or a bash. I think it also works. It works the same. And we'll start a new project.
So the key thing here is you've got there's a NuGet package, zomp.efcore.windowsfunction.sql server, and we're adding the pre-release version of that package to a project that we're setting up. Right?
Yeah, that's correct. Yeah. So it's.
By the way, just a slight digression here, but Shay and I are talking about the fact that we don't have links for some of these shows, so I'm going to create a page in our docs which has all the links for each of these shows. So in the future, we can just direct you to there whenever you need a link, because I haven't put together a link for this, but we will do that in the coming week, I promise. So these links will be available.
By the way, this document, should we like just put it in the chat or something so that people can follow along?
If you you can, or you can just send your PowerPoint to me and Shay, and then I'll find a place to like put, like I was saying, with the links and stuff to put samples or whatever. We just need to have something for that.
Okay, no problem. All right, so let's run this.
So while that's happening, I'll just state the obvious. The main problem here is EF does not yet support window functions, just in case that wasn't clear. So we support, for example, group by and aggregate functions, but we don't support, EF just doesn't have the infrastructure for this yet. It's absolutely something that I think everybody agrees, I think, on the team that we should, and it's also highly voted, by the way. It's something that people have been asking for, but we just have too much stuff, that is more high priority for us at the moment. So I sincerely hope that one day, this will be part of EF as well, this kind of thing. But in the meantime, I'm absolutely thrilled to see what Victor is showing, as a community extension, and I think it's a wonderful story of,
yeah, absolutely.
That's how it should work, basically.
Because one of the, I don't want to go too much into this, but one of the reasons that one of our motivations for EF Core was to be extensible, so that when the EF team was not able to do everything, people could write extensions, and it's great seeing that happen. And that's very much part of the motivation and the philosophy behind EF, that it should work well with extensions.
Indeed.
So basically, I'm just going to drop 2 files into this project. It didn't drop into the right folder.
Demos never work.
Nah, it's all gonna work.
As always.
Yay.
Okay, so we have 2 files here. Let's start with this one. It's a test row. It's got ID and it's got call 1. Okay, pretty standard, right? Same data. Like this is like the seeding data. It's a record and it's got like an internal static class. Nothing major. We also have a test DB context, which derives from DB context. It has a set of test rows. It basically tells that ID is already generated, don't bother generating the ID. And this is the data it's seeding. It uses SQL Server. It could also use SQLite and Postgres. Right now, it just uses SQL Server.
So that's an important point. So the extensions that you have for EF Core work with SQL Server, SQLite, and Postgres. Is that correct?
Yeah.
Awesome.
Yeah, that's correct.
Really
and almost Oracle's almost done as well.
Nice.
There is, and then someone also requested MySQL. That I mean, if you do one of them, then the rest are generally easier, right? It's kind of like with languages. You learn the more languages you know, the easier they come later on.
I mean that is definitely true. Although sometimes with database functions, the different databases can be so different that it ends up not being the case. But it's really good that was the case here, and it's great to have it for multiple databases.
Indeed.
Yeah. Okay, and then the other thing that you need to do is you need to do this use window function, which is it tells the engine, the EF Core engine, that when it does translations and all kind of pre-processing, post-processing, whatnot, it needs to go through the Zomp extension. Okay.
So this is the normal pattern that we have that people should have seen if they've used other extensions from us or otherwise, where in add DB context or on configuring, you call use and then the extension to use it.
Okay, let's go back to, well, actually, don't need to go back to the demo. We just need to go to our main program file. And I'm going to paste the query. the simplest query. Okay, I guess first thing we should do is we need to instantiate this context.
Yep.
And all the red's gone. So let's see what. So basically, what it takes the test rows and it selects the count, and there is this EF functions over. It kind of doesn't do anything in this point, and but I don't know. That's kind of like an API decision that we've made. I don't know. We can. Not sure.
That's basically your first example of having the count of all rows, right?
Yeah, that's correct. Yeah.
That actually can be very useful, by the way. It's maybe not the typical example of what you use window functions for, but it is very useful. We recently had an issue around pagination where you want to put the total number of rows, right? So as another column. So that's the way to do it.
Yeah.
Mm-hmm. Yeah. Okay. So basically. Mm-hmm.
So just walking through this query a little bit. So what we have here, the way we've taught this to do a window function is by using the EF functions over. Is that correct?
Sorry,
so the way we've told EF that we want to use a window function here is by using the EF functions.over. Is that correct?
It's more count, right? So it's more like because count is not part. It's an extension. It's not part of the.
Right.
So first it sees when it parses it. I think first it sees the count, and then later on it parses the arguments of count, and it's over. Right?
I see. So EF functions count is actually a specific version of count, a specific function mapping that maps count as a window function.
Yeah,
is that more accurate? Okay, and then the EF function over tells it what to count over, basically.
Yeah, so if I do an F12 into it, right? You can see that this is like a, I guess, decompile source.
Yeah.
This I'm not supposed to see as subquery. This is supposed to be private. I'm not sure why I'm seeing this, but it's definitely internal. In any case, we have average, right, and then bunch of different return types, and so a whole bunch of counts too, and all these are window functions. Lag has, because lag, some of them have a lot of arguments and different arguments, and some arguments are optional, so there is a need to generate these overloads. Right, so and something like rank is pretty simple, and row number is pretty simple. There is not too many overloads, but
makes sense.
Okay, so there we go. It's so this is count, right? Let's do another one. I don't know if I should be doing this, but if you don't want to type EF functions all the time, you can basically just do this, like replace it with F. It's something that I just thought of yesterday, just because when I was practicing on a small screen, because I know people watch it on their cell phones, right? So you could. I don't know if it's a good practice, honestly. I don't think this should be in a production code, but you can do this as well. And then it becomes quite tiny.
It's not bad.
Yeah. All right, and then let's also do the minimum function that we had. guess I should comment this one out because it's a different kind of query and they are not compatible. So basically, you see the same results as from the slides, right?
So this time we're calling the min function, which is the function mapping for a window function using that results in min values, and then we have an f.over, and you've got an order by clause on there, which matches the SQL we saw in the first example, right, where we were saying order by, and so then this will then result in that behavior that Shay was describing, where it's maintaining the state on for each row and calculating the min based on that, right?
Yeah, that's
it's all very intuitive, I think.
Me too.
It's very nice. Yeah.
I like it.
Yeah.
Yeah, and then also you have the SQL here, so yeah.
Mm-hmm. Absolutely,
Okay.
yeah.
One interesting thing whenever you do something in EF is to design and think about the link that you will use to express the SQL that you're shooting for, right? So in this case, you've added count and min to EF functions, and also over and so on. It looks really nice, I have to say. It's not easy to design the link expression, like the link way of expressing things. It's a thing we have to deal with every time. So good job on that.
Thanks. All right, cool. So let's move to the next example.
Mm-hmm.
Where am I? Okay, so we've gone over this. We've gone over this.
Cool.
And this is probably not the best slide, but it kind of shows the selector of link, right? So you've got the function name, you have the over. I don't know. Maybe I was thinking maybe over. We can over never has any arguments, right? It basically just says this is a window function. So I wasn't when I was designing, I wasn't sure if we even needed to have it, and I just put it in there just because it made chaining a little simpler.
Yes.
But
I mean that's the reason we have ef.functions and not just ef and then you have functions, right? Because you've got to have something that you can hang stuff off and chain things off. I think over is fine. I mean, there might be a different way of doing it, but to me that seems like we were saying fairly intuitive.
Okay, cool.
Yeah, I mean, there's also I also have to say there are certain things that we can do inside EF if this is ever implemented, which it will be. I really hope so. If we implement this in EF, there are certain tricks in terms of the links syntax we can support that you probably can't do from an extension. It becomes much more complicated. The tools at the disposal of an extension writer unfortunately are not the full things that can be done when you're in the core. So I'm looking at this and I have some ideas in my head which we'll revisit whatever in a year or two when we get around to maybe actually doing this. But I think it's completely fine. It actually looks pretty good to me.
Yeah,
nice.
I agree.
Yeah. And then
I have a perhaps slightly strange question. That is actually related to those chained by methods. So those methods are clearly ones that we all recognize as being things that, well, at least the first three are things that you get on iQueryable. Does over return an iQueryable, or does it return some other interface that you're then chaining an order by on?
I don't think it returns iQueryable. It returns.
Okay, interesting. Yeah.
It returns something that nobody uses.
Yeah.
Right?
Yes.
Completely just for.
Just for the Fluent API. Yeah, exactly.
Yeah.
Yeah,
And
I mean, the reason I brought it up is because Diego, Vega, Shay, and myself have been having this conversation about link APIs and whether to do this or whether to return iQueryable and the pros and cons. And I think we would have come to the same conclusion here that you did, which is don't do iQueryable, but make the shape be something that people are expecting so that it meets their expectations, but you then don't end up being in this place where you've got an unlimited set of extensibility that makes no sense, because you can't do unlimited things on it.
I'll also say over is technically not an expression. It's a clause inside. It doesn't return rows. It just tells the window function how to operate and how to do its thing.
Yeah.
Right. So it's not in itself a conceptual queryable. And as you've said, it also so it basically this is being used to model what you can put inside the parentheses of over, which is ordering and partitioning and various other things. It definitely does not support the full array of queryable operators. Even it doesn't make any sense for that to actually work. Anyway.
Yeah. It's almost like a specification pattern.
Well, and then these are the window functions that are supported currently. Basically, I think we started from min, max, sum, average, and then we added all these ones. Ranking functions, I think they're kind of, there are like categories of them. I think these ones are called ranking functions. And I think aggregate and these ones are analytics, lead and lag, but don't quote me on that. They kind of have different functionalities from one another. So
I haven't heard of some of these. Like, I don't even know if that's lead or lead. I assume it's lead, but it could be lead.
These ones are a beauty. I actually, these ones are. We'll talk about them very soon.
Okay, let's do that.
Okay, right, and then like I mentioned before, these are the providers that are supported. Let's keep going. Now, this is from an Oracle website, and I'm not sure, but I think that Oracle is the one that kind of sets the standard for window functions. Is that right?
I don't know the history at all.
I'm not sure that's right, at least when it comes. So I know, I don't know it either. I don't have the answer either, but I would assume sometimes SQL Server follows the Oracle syntax in some things. Postgres not necessarily. There's an ANSI SQL standard that usually is the thing that at least determines what Postgres does. Postgres tends to be very SQL standard compliant, but at the end of the day, maybe it doesn't matter that much, right? I don't know.
So like I guess so far these functions that are currently implemented, they look the same in whatever provider you choose, and then now there comes a point where they start differing, like the names start differing. There's like this last, and it's named differently in SQL Server and in Oracle. So there's going to be like some also design decisions what to call them, because in this extension they should all be named the same, but that's in the future. So we have these rows and ranges and between and unbounded and preceding. So all of this is implemented in the extension, and I'm going to show just like one example of using, I think it's called restriction. So here's a SQL where we want to get a maximum in this window function, but we only want to consider two entries that preceded the current entry and one entry that followed the current entry.
Wow.
Like a sliding window, right? This is basically why we call these a window functions in a sense.
Yeah.
But it's interesting there that you can actually go ahead, right, with following. Like, because when Shay was describing it and when I've heard it talked before, that's a little strange to me. But, I guess it's just implementation detail. I mean, it makes sense logically. It's just, but...
And it still can be implemented very efficiently. So the window, the database still processes, the rows.
Exactly.
Like it just knows to slide a window, basically. I mean, I'm not going into the actual implementation, but right. I mean, like
the window doesn't have to end at the last row. The window can be, yes.
Exactly. Like, think
Yeah.
about this, like you can do moving averages here. That's amazing. Like
Yes.
if you order by the date, and then you can do a moving average of the value for that date, but also for the date before and the date after. This is like absolutely amazing and impossible to do without window functions. Like super complicated, if at all possible, right? So it's really cool.
Yeah. Yeah.
Yeah. So and then you I don't know if we should paste this into the SQL.
I think we can just look at it. We don't need to run every example.
Yeah. Yeah. So basically, while 10 is in the window, right? It's all going to do 10 now because it's two preceding, right? So at this row, it doesn't see the 10 anymore. So -1 is the maximum because it just goes between -1 and -1, right? So yeah, let's keep going.
Super cool.
Yeah. Now let's do this on the SQL side. What we want to do is we want to deal with the fifth row, and let's do it with raw SQL.
Oh, interesting. There's something here that's interesting to me, but I'll ask afterwards. So you're going to introduce us to the row number window function now, I think.
Yeah, that's the one. I don't think we've dealt with that one before. Don't think I can introduce to all of them, but row number is super important. It's like anytime you're dealing with a grid, and you really wanna it's I think I used it in grids more than anywhere else. So let's select first. Let's disable this plan first. All right, so you're selecting, and then you can see that you have your ID, your column, and then this one's just numbered 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay.
So this is creating a row number in a new column for each row in the results. Is that correct? Very nice.
Yeah. And then I don't think I've shown partition by ever. So just because
that's important. Yeah.
Let's just do that just because we're on the same topic. There is this thing called partition by, and basically this is where do we want to start the count from, I guess. Well, let's do maybe ID over 10.
That's going to be a bit complicated, more complex than the usual example, but I think it's fine. We can try.
Okay, let's do ID more than 10.
So I'm used to seeing
one word.
Oh, what is it?
Partition by one word?
No, I'm used to seeing it before the order by. I'm wondering if this is an ordering of the clauses inside the over.
Yeah.
I'm no expert.
Well, see, that's at the demo bots.
You can try just to do it by call one, just partition by call one.
Okay, no, that works, right? So as long as, okay, let's also do this one too. We'll place it as a column. All right. So ID over 10 goes 0 because it's basically like this ID integer divided by 10, right? So it's going to be 0, 0, 0, 0, and then here it's 11, so it's going to be 1, and then here it's 23, so it's going to be 2. So your row number is just for this group that you're dealing with, right? So it's going to go 1, 2, 3, 4, and then this is a new group, so it's going to go again 1, 2, 3, 4, and then this is a new group, and it's just going to go 1. Does that make sense?
Yep. So it's partitioning all of the rows into groups, basically, and it resets the row count for each group, so you get essentially pages, for want of a better word, in the resulting set.
Another way to look at it, this actually does look a lot like group by, and the canonical example is you can do a partition by a department, right? For example,
Yeah.
you can get the average salary by department. So you can do this with a group by, but then you get one row per department. Whereas window functions, once again, don't reduce the rows at all. So they keep every single employee, and they just give you within, it just means that the window function can only operate on things within the department. For example, you can have a count of how many employees, how many rows there are in the department by doing count over partition by department name. And that will give you, for each row, an additional column that gives you the count for that department. So before we saw an empty over, which means take all the rows in the table, and that did the count over everything. If you partition by the department or anything else, then that becomes your window, to use the term, right? That becomes the thing that you want to work with, which is, again, partition by is extremely useful. It's very, very powerful.
So if I'm understanding it correctly, if I wanted, for example, to work out, let's say I have a list of employees and they're each belong to a different department. So we've got 10 people in HR and 10 people in accounting or whatever. And I want to say, okay, calculate the average of salary for everybody in HR and the average salary for everybody in marketing or whatever. But then for each row, I also want to say, that person, how much are they above or below their average? So I need the average there, but I also need one row for everyone, and I can use that average to calculate that, and I get a very nice, in one query, set of results there, right?
I think that's a more advanced scenario already, but that's the direction. So you could get the average salary of the department is simple, right? That's just average over the column that indicates the department, and you get a new column. So it's not a new row; it's a new column.
Right.
Each row that gives you the average for that department. But then you can have another one. So you have two. You can have two window functions. And,
yes.
I'm not knowledgeable. Probably Victor can say more, but you should be able to reference that average. So the other column that is the result of a window function from yet another window function. Possibly.
But that was a little bit more complex than what I was describing. But even so, it just illustrates that you can go even further. Yes. Good stuff.
All right, so let's go back to not having a partition by and see the results.
Yeah.
Okay, and now I'd like to just basically concentrate on row number 5. Okay, so what I'm doing in the second query is I'm moving this row number into the where clause, and I say, give me all the stuff where row number, whatever we said with the same expression, is equal to 5. So let's run this. It doesn't work.
That's what I wanted to ask you about. By the way, when you show the slide, exactly this.
yeah. Okay. Well, this is a purposeful failure, right? It's supposed to fail, and we're ready for it. So let's go into the next coding thing. We'll just do it in. I don't care that it doesn't work. I still want to do it in EF Core.
Okay.
Maybe it's gonna work in EF Core.
Maybe.
Oh wow! I think we're gonna get really impressed now. I sense some impressing. I want to see what this looks like. Wow.
So row number, so it's 11, right? You've got a slightly different SQL here. Let's see what's going on here. So basically, it goes. So this is like the new filter. Just gonna run it just so one row, and it's the same, the one row that we were looking for. So what's going on here? The EF Core saw that inside the where clause there is a window function, and it knows it's not going to be able to put it into the where clause. So what it does, it rewrote the expression tree to get us to this position. Okay,
Yep.
so what do we have here? So, sorry, go ahead, Arthur. Yeah, so what do we have here? We have like a select, then we have a subquery, then we have a filter, right? Okay. So let's look at the transformation that's happening behind the scenes. Okay, basically this is what we just saw. Yeah.
I mean, just go back to the previous slide. I just want to clarify, like, what the meaning of this query is, right? So the idea here is that we're giving every row a row number in the subquery, and then in the outer query we discard all of them except for the one that we labeled 5, and so that just gives us basically it just says pull out the one that's the 5th one out of this set. That's the idea, right?
Yes, that's correct.
Okay, just so as I've got that straight. Okay, continue.
Yeah, and that something like this happens when you have like a grid, and let's say you're on row number 300, and then you want to say delete. Right?
Yeah.
And it can do it this way if it doesn't have that, like it doesn't always have the ID. If it has the ID, it's a lot safer to do it by ID, but you don't always have the ID. Right? So for example, an example of this would be, like this is like a really basic case, but let's say you have a grid with 10 million entries, and some of them aren't even loaded because it's too much to load, right? And then you just decided to like scroll to like 100 row, and then scroll all the way down to like maybe just
so
before
just
the end.
sample the data, basically, just do a sampling.
Yeah, and then you say I want to delete all these ones, so it has to delete by row numbers, right? So
yeah,
there is no other way. Okay, so but so what's happening here, and this is kind of like more where we might lose the audience a little bit because this goes into the pre-process. Basically, and you guys can talk more than I can, but there are all these services in EF Core, and they're all public, and all of them can be overwritten with your own services, and you can basically either call the base functionality or just do your own stuff, and it's totally up to you, right?
Yep.
So one of the services is the one that pre-processes an expression, right? It moves things around, it simplifies it. If there's like I think if something is retrieved twice, it just drops one of those entries, right? And then eventually, at the end of the pipe, we get this expression, which is the before, and then usually it would put it into take this expression, put it into the where clause, and take this expression and put it into select and just run it, and then it would crash on SQL. So what we have to do instead is we have to visit this expression, see that there is a window function, determine its type, remember its node, and make a select instead, okay? Because you can have a window function and select. Now, this select, right? Where are you selecting in? Like, you have to have some kind of a projection. What are you selecting into? And that basically depends on how many window function expressions you have in your web calls, because you could have 10 of them, right? So because you have 10 of them, and these 10 expressions could be of different type. Like you can have min, which is min of what, right? Like it could be min of bytes too, right? Like then it's a byte array. You can have a count, which is going to be long and stuff like this. So you have to construct your own type. So this my unknown is a type that is getting constructed. I mean, I don't know if there's like any better way of doing it, but that's what we've done here. Okay, so you're generating your own type on the fly through IL, and then every type has a getter and a setter. You put this in, then you do a subquery, which is internal, right? Nobody can do that except for, like, it gets generated by extension, and then it gets executed by extension, and then you do your where, and then you do your usual select, right? So it's kind of like described here, right? Mm-hmm. My norm is getting generated. Yeah, basically just what I said.
So I definitely didn't expect us to go into query pipeline internals in this.
This is great,
super cool. Super cool, exactly. Like, that's not negative at all. That's to the contrary. I love this sort of deep stuff. Just to make sure the audience is still with us on what the problem here that's also being solved or fixed, I'll just re-say it. So basically, you can't use window functions in where clauses. Databases don't support that. They are only supported in projections and in order bys. So if a user does put it in link, we can't just translate it like one-to-one, right? The link does not translate to SQL one-to-one. But instead, what we can do, like to use the EF Core terminology here, when we see this kind of thing, we perform a subquery pushdown. So we take the query as it is before the where is applied, and we push it down into a subquery, and that puts the row version into the select of that subquery. So we've basically rewritten things. We shuffled the query tree a little bit so that the row number, the window function, ends up in the select, in the projection, which is where it's supported. And then that's one subquery, and we can compose the where on top, right? So we've kind of we kind of took it out of the where, and we put it inside the subquery projection instead, which is the kind of stuff that EF does all the time internally. So if you're a developer working on EF itself on the query pipeline like me, then that's very, 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 very familiar. And we do this all the time, in fact. Like whenever you do, even without window functions, if you do a where, like in link, that can do many things. Sometimes it will just become a where on your select. But if you've already done a group bind, then that will actually become the having clause instead. And in other cases, if you've already done some other operators, then we'll have to perform a push down into a subquery and compose the where on top of that. So this sort of thing is very, very common when you're dealing with translating link to SQL. It's just super cool to see this being done in an extension. Usually this is very, let's say, deep query pipeline stuff. So it's the first time I'm actually seeing this in an external query pipeline. So well done. Yes, Arthur.
So yeah, just to add a little bit to that, we fairly, I don't know, I'm not saying we frequently, it's not uncommon for us to get questions from people who want to manipulate link and change the expression tree. And I think this is a great example of how you can do that with an extension. But as Victor pointed out, EF has a lot of these visitors, and figuring out which visitor you want to override and which functionality you want to add, and how you want that all to fit together, that's not trivial. As Shay is saying, that's internal query pipeline type stuff. You can do it. It's just difficult. And so you have to know which visitor to go and manipulate and how. And it's really not a simple thing like you might be able to do with an interceptor, where you can just say, oh, here's the query, just give me that and I'll rewrite it. It doesn't work like that. You've got to go through this in the right steps, in the right order, to really translate it. And so it's great, Victor, showing that is doable from extensions, and you can do this. It's just not easy because Link is not easy, basically.
Yeah, Victor's showing us something that looks
and then basically what I had to do. So I think this was basically like this is almost like this is the base implementation of the service that I had to override, and I had to basically add 2 lines here. This join detector, because join, like I don't have an example for this, but join, if you have a window function inside the join, you also have to push it into subquery. Otherwise, it's just gonna float to the top and mess up the query. So that's one addition that I had to make. And then so window function inside where detector is basically like, it's another layer of visiting that I had to add so that this thing works.
So
well done.
We should, yeah, very good. We should definitely have a follow-up on this just between us, so that we can see whether we want to add different extensibility points or anything else just to make this even easier. That's another great thing, that if anybody who does do this, giving us feedback on where we can make the extensibility better is also very useful to us. Because as everybody knows, if you write extensibility points but you never use them, then they're almost always the wrong extensibility points, right? So So I was just going to say, I think we've done an hour, and I think we've covered a lot of stuff. So maybe this is a good place to wrap up with the expression tree stuff, and certainly talk about where you're doing ref emit, and then maybe we'll end on that. Oh, is that for creating the type?
Ah.
So what was that?
So you're emitting IL in order to create the type.
Oh yeah. Let me just show that, just because it's on the same topic, right?
Yeah, that's a bit extreme.
Yeah. So people may or may not know this. I never know what normal standard knowledge or not. But there's a lot of code generation you can do by creating an expression tree and compiling it into a delegate, for example. But you can't create .NET types that way. If you want to create a type, you have to generate IL. That's the only way to do it dynamically, which is a pain, and why you have to do things like this. And this is what Castle Dynamic Proxies does to create proxy types as well. It does this kind of thing.
Yeah, and I really wanted to avoid it, but then when I did it, it was, that's cool. Right, so it's got like, it takes a name, which name is going to be like P1, P2, P3, right? Type, which type is getting created, and the replacement. Replacement is just the node that basically, like, after like when we first visit it, we see it's a window function. We're like saving that node, and then later on we're replacing it with that parameter P1, P2, or P3, where we actually do the selection. So in the where clause, I don't know if what I'm saying makes sense, right?
Yeah.
Right. So basically we're just remembering it and going back. Yeah. There's like more stuff here to cover, but not that much. There's like this last known puzzle. We can maybe do it next session or whatnot.
No, this has been really good. It's yeah, I think it's getting very deep here at this point, which is great. Maybe it's something that we should take offline, the anonymous type creation and stuff, because I'm really interested in actually digging into the technical need for that a bit more. But I think for right now, we've got an hour and 7 minutes on this, and it's pretty intense stuff. So this has been really great. Thanks for coming and showing us all this stuff. Yeah, it's great to see EF extensions like this, and we always really appreciate it. So so thank you. Shai, you have any closing thoughts?
Yeah, no, I mean, I just love what I saw, like you said as well, and thank you, Victor, for making this possible on EF, as you know, while it's not yet, you know, in EF itself core, and I mean, there's always this thing where I think you've done a great thing. At some point, I think we all hope that it will be some sort of in the box as well. So on. There's always that thing as well, which is good, and yet also, you know, sometimes you know, has its like problematic sides or whatever. But definitely in the meantime, until we get there, this is absolutely great to see, and definitely the technical challenges here are beyond what we usually see in extensions. So this is quite impressive. Well done.
Yeah, great stuff. Okay, so thanks everybody for watching, and we will do another one of these once we've figured out what we should do. All right, see you everyone. Bye. Thanks again, Victor.
Bye.